check. Okay, okay. I see that the video is live. Now, just let me know in the comments if the audio works, and we should be good to go. I see some nice comments in the chat. Thank you very much for that comment. But in the meantime, I'd appreciate if any of you can let me know that the audio is working. That would be great. But yeah, thank you very much. Mic check 1 2 1 2. Audio is great. Cool. Okay, guys. So today, yeah, I'm a little bit stressed about this stream, to be honest with you, because we are going to do live demo of Roboflow Rapid, one of the latest and greatest features that we have in Roboflow. And yeah, I'm pretty stressed about it, but I really hope everything will go well. So what we are going to do today is we are going to train a model, or I should rather say distill the model, and deploy it from the raw data. I will collect data on the stream, we'll upload it into the platform on the stream. All that will happen during the stream, and yeah, then we'll run the model over the API to run the detection. I was thinking about like cool use case that I can execute on my desk. I didn't really have a lot of time, guys. So I'm sorry for that. But we are going to detect gummy bears. And we are going to group them by color. So we'll have a separate class for each color. I showed a little bit, kind of like a short demo of that on Twitter, but today we are going to do everything from start to finish. So let me show you the setup. I'm not sure if you guys will hear me well, but we'll see. So here's the setup. I have displaced over here. I have the light that shines on that space, and I have another phone that I will use to collect data. So all that will happen during the live right now. Let me just put the camera back in place. I hope we'll not lose connection here. And to make it a little bit easier for you guys to follow, I will rotate the camera that is on my desk to point in the right spot, so that you can guys see that I actually collect the data. Let me also adjust the mic a little bit, so I hope you guys will hear me better. What model does the Rapid use in backend? Rapid use SAM3 to run kind of like the distillation from, so as a teacher model, and RF-DETR as a go-to model that we are going to distill to. Okay, so I have few gummy bears, so we'll collect the data set of those images. So in the meantime, when you guys you guys wait for me to create a little bit like kind of, I hope, interesting and useful data set that we can use to distill from, and I will collect few photos here and there. So you saw that I took like one photo of like one of each. Now I'm putting few of the same classes here and there. Let's do like few more. So let's have like a just the mix of all of them. So that's photo number 3. And maybe what else we can do? maybe one more of all of them grouped in different places. Maybe like this. Cool. So that's photo number I guess 4. So those will be the photos that we'll use to like create instructions from for our teacher model to teach. Now I will switch into the video mode and we'll create a video that we'll use for the inference. So we'll have like a video of me just throwing those gummy bears on the paper sheet. Cool. Okay, so we have the data set. I can sit back down in the meantime. Let me just adjust the camera. Yeah, like I said, it's a pretty crazy stream today because we are doing a lot of things that we usually don't do, like for example, change the position of the camera. Thank you very much. I appreciate that. I hope that we'll manage to train that model. So far, so good. We collected the data, I think. Okay, so here's the rapid. In the meantime, let me just use AirDrop to send those images and videos onto my laptop. So just give me a second. Okay. Save to downloads. Okay, cool. I think I have them. Looks like we are all good. So now let's upload those into Rapid. And what are like Rapid has this feature that it tells you pretty much what classes you could prompt for, like as a kind of like suggestion. But you can type in anything you want. So indeed, we will look for gummies, yeah, but we want to have split by class. So let's do red gummy, green gummy, yellow gummy, and orange. Yeah, because those were the classes that we had. So let's upload that and ask the model to annotate them. Okay, this will be pretty good image to start from. So because we can see a lot of things at once. So what I would like to have is adjust those classes so that they would match the class name. So we have green one, we have orange. So let's change the color first. And now there is a slider here that allows us to specify where is this point between yellow and orange where we would like to do the split. So now we kind of like, you saw that initially the model said, oh, that's orange. That wasn't orange, that was yellow. So we have a way to kind of like specify the place where orange start and yellow ends. By the way, let's just make it more vibrant. So we have red gummy, and once again, I guess that kind of like split between yellow and orange is hard to get in the first try. So that's how we do that. So we adjusted those thresholds. I used that one image as a kind of like good testing ground for that model. And now let's go back to our other images and see how it will do. So that's an image that was unseen previously, and we can turn off the labels so that we can see better. Yeah, detected the red ones, the yellow one, orange and greens, so that works fine. By the way, if you have any questions along the way, I'm super happy to answer. In the meantime, looks like this one will be a little bit chaotic, so we would most likely need to adjust our threshold. So look like we have kind of like a double detection here. Some of the orange ones ended up So let's. I should probably move this way. Okay, cool. So we have yellows, reds, and orange that work well on our test image here. Yeah. Okay. 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 So now I think we are good on all. Okay, the green one is I guess still missing. Okay, cool. So now all of the yellows are yellow, all of the orange are okay. Greens are okay. On this image, we are all good. On this image, we are all good. And on this image, yes, we have like a slight double detection. Yeah, I'm not sure we'll be able to get it all good on all images. We'll see. Yeah, and on most of the images we can do it quite precisely. For some reason we can't really do it well here. Okay, so let's go for those cases, and that's where we leave it. Cool. Okay, so that's how we annotate the data. Now, how do we deploy the model? Okay, so to deploy the model, it's actually pretty easy. First, we click run on all images, and then we can deploy. But let's have it tested on the video that we uploaded, that we made. Yeah, so we are just uploading the video into the session. Takes a little bit more time than I expected. Okay, cool. Now we can adjust where we would like it to have start and finish, because we only can upload 10 seconds of the video into the Rapid editor. So that's what we are doing. So we trimmed the video, and now we can run it. And Rapid has a pretty cool feature that it shows you the kind of like the detections as they go, so we can see what's happening here. And now we have a model that is capable of processing the video. Cool. So if we have the model, what's the next step? So let's publish the model. So now when we publish, we get an API endpoint that we can use to query the model remotely over the HTTP. And there is JavaScript supported, Python supported, and the Bash terminal, but I am the Python guy, so we'll use Python. So those are the instructions. All you need to do right now to use that model is we need to install the inference SDK, and then we create the client with our endpoint, pass the API key, and then we can send images and videos and get the results. Cool. Okay, so let's do that. I have the notebook up and running because I was testing a few things before the stream. So now let me show you how to run it. So to actually run that model, we need to first have the Roboflow API key. So to kind of like distill the model and play with it inside the editor, you don't need the API key. But once you want to deploy it and run it, you will need the API key. So that's what I pass here, and then I create the client. The client just directs the traffic onto the endpoint that will host that particular model, and takes the API key. Cool. And now let me just upload our test images into the editor so that I can show you that you can just run the inference remotely. So the name of our workflow that we just distilled is here. So pretty similar to the one that I created, just with the different index at the end. And our path is here. So once we run it, we should get a response. Hopefully soon. Okay. Okay, I'm not sure. I hope it works. At least does it look like, because we got the response, and if we print part of that response, we'll see. So this is the single detection that we got over the API. So it looks like we have valid bounding box here, plus confidence, plus class ID, and information about kind of like the polygon that enclose our segmentation object. Cool. Okay. So now what we can do is we can try to visualize those. So I created a kind of like fairly small code snippet that allows you to parse that response into supervision detections object. So when we run this, we got detections. And we can take a look. Oh, sorry. If it parsed correctly. So at least we have our detections. That looks good. And the boxes look fairly okay. So now let's visualize those. So I'm passing the path to the image, and I'm using supervision annotators to visualize the result. So we can see the colors don't match anymore, but if we take a closer look at the actual labels that are getting displayed, so we have orange gummies, we have red gummies, we have yellow gummies, and we have green gummies. And that is pretty much what it is, because if we would turn off the mask visualization, we would see that those are green, those are orange, those are red, and those are yellow. Yeah. So this is how you do it. You can pretty much go from a simple idea of just annotating, of just detecting objects, train the model in just a few minutes, and deploy it over the API. All that pretty much zero shot, yeah, with like no manual annotations being done. Yeah. Cool. Yeah, that's pretty much the whole demo that I had prepared. But we can go. What I would like to do maybe is kind of like show you what's possible with Rapid. So we can throw in a few examples. So for example, let's switch back to the screen, and I will show you a few examples of prompting. By the way, if you have any questions about like how the model works, and what can you detect, and maybe you have some ideas for us experimenting with different prompts during the stream, just let me know. But in the meantime, I will just show you a few quick tests. So that's one of the videos that I used for the basketball AI recently. And yeah, so what do we have here is we have a basketball play from a game. And importantly, there are two teams playing, the Celtics and the Knicks. And now let's try to detect those players. Yeah, so let's start with something easy. So let's pick player and try to detect them. And immediately we see that that Rapid can detect the players, but we have that additional detection that is happening here. It's something that we probably wouldn't like to have. So let's try active player. active player, and let's try to find those objects. Okay, that guy is still being highlighted. Okay, so now we don't see him, but what I would, for example, like to do is split them in between teams. So let's try to have active white player and maybe active blue player. Cool. Okay, so let's try to find those objects right now, and yeah, let's make blue blue, and let's make white white. Can I make it white? Yeah. Cool. Okay, so now we have the split between two teams for a single frame, and let's try different frames. So let's try what will happen on different frames here. Here the split is correct. Okay, here we are. Okay, let's try to filter this guy that's constantly showing up in the corner. Cool. Okay, so looks like the model can handle it. Let's run the model on entire video. I simply cannot get it to run on T4 on Colab. Have you had any lag? It works locally on 4060. What model are you talking about? Are you talking about some free or another model? So now you can see we have the model that would be capable of detecting players from those two teams, and if we would like to deploy it, all we do is we click here and we can run the inference once again. Cool. Yeah, I'd say that's pretty much everything that I had prepared for today. So I wanted to show you how to go from like an idea that you have on your desk into like a running model in I'd say just a few minutes. Yeah, appreciate you guys visiting the stream. That was pretty much something that we came up without a lot of time to prepare. But I think that it's a pretty cool visualization of what's possible with that technology and that idea. Yeah, if you have any questions, that would be a good time. Otherwise, yeah. Otherwise, that's a wrap. So, so just let me know, guys. I'll wait like 20 seconds. Can we use it for football free kicks analytics? Because occlusions are very much difficult to handle. Depends on what do you want to detect in that free kick. You want to track the ball during the free kick, or you would like to do something else. I know this is not really related to the current topic, but do you have any news on RF-DETR seg or RF-DETR variants with Dino? I think we will. So question is about new variants with Dino v3 for RF-DETR segmentation, RF-DETR detection. I'm not sure how advanced the work on that is. I know that we will release larger checkpoints for detection soon. So stay tuned for that. It all depends on the priorities that the models team have. So no clear dates. At least I don't know about them. The recording will be available. Yeah, we will keep it on our YouTube channel, so you can just look it up and watch it from the beginning. Is the model downloadable? So far, no. I think that right now it's only over the API, but the idea is that we will probably make them runnable locally at some point. But yeah, it's just very much a concept right now, something that we want to kind of like refine first, and then maybe make it available locally as well. What are the privacy concerns of the videos, images we upload? Do they become your IP? If you have a paid account, no. If you have free account, then I advise you to take a look at the kind of like terms of use. For example, all the data sets that are on the Roboflow universe that are publicly searchable and browsable are coming from free accounts that are using Roboflow on the, you know, without the proper enterprise license. So to some extent, it's usually like if you use free account, then it goes into universe, and it's pretty much accessible to other users, and they can browse it. Similar to like GitHub, yeah, have private repositories and public repositories. I'm trying to do it on Hockey Games, and I don't know where to start. I mean, I think it's probably quite similar to the basketball example that I just showed. Yeah. So I think that what you can do is just, you know, open up rapid.roboflow.com and just you know, take like 2 videos that you have of the hockey games and just try to play with what's possible. Some things are incredibly easy to define with text, and some things are quite complex. So you know, you just need to test it out. I think that with time, Rapid will be, you know, more and more powerful, and more things will be doable without any annotations. But for the time being, you need to kind of like really test out your use case, try different prompts, because very often, like you see, like if we try player, very often we can get somebody from the stands. So you need to be kind of like willing to spend a little bit of time and play with different prompts. I'm working on the player movement while taking corners and free kicks in football. Could this be useful? Yeah, I think this can certainly be useful, especially if you want to, like, in the first stage of the pipeline, so when you want to detect the players. But of course, this only gives you a position of the player on the frame. So for you to be able to know where the player is actually on the football pitch, you would need to do perspective conversion. We actually have YouTube tutorial covering football, that conversion in football. So take a look. I think you know, you will find some cool pro tips in that video. Cool. I don't see any more questions. So if that's all, then thank you very much for joining. Feel free to reach out to me over the LinkedIn or X if anything will come to your mind. And yeah, otherwise, have a great afternoon, guys, and see you next time. I'm already cooking, you know, collab and stream for upcoming Moondream, you know, stream that we'll have. So yeah, a lot of open source streams coming soon. Cool. See you. Goodbye.